Hello, and welcome to I Know Dino, the Big Dinosaur Podcast, where we cover news, interviews, and discussions of all things dinosaur.
Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today's episode is brought to you by TRX Dinosaurs. They have innovative dinosaur art, affordable posable dinosaur sculptures, as well as puppets. And you can learn more at trxdinosaurs.com or on Instagram at trxdinosaurs. This week we have Dinosaur of the Day Camarasaurus, and we have a bunch of dinosaur news. But first, we would like to thank some of our Stegosaurus patrons. This week we'd like to thank Scotty, Jackson, Megan Dixon, Kessler, Beth and Scott Wilson, and Tristan Jules.
Yes, thank you so much, everybody. We really appreciate all of your support. And we appreciate all of our patrons' support. And if you would like to join our growing community, check out our page at patreon.com/iknowdino.
Yep, and you can be like Tristan, who just joined. Thanks, Tristan.
Yay, welcome.
This week we have 3 new dinosaurs.
What?
Yeah. The first one I'm going to talk about was written by Oliver Rahout and Diego Pol, and they published a new theropod from Argentina.
Not a sauropod.
Yeah, mixing it up. It's from Chubut, Argentina, I think. It's in Patagonia, and it's from the late Jurassic in the ballpark of 150 million years ago. And like I said, it's a Jurassic theropod from Argentina, and it's the first late Jurassic theropod that has been found in Argentina. So something of note. They named it Pandoravenator fernandezorum, and Pandoravenator would translate to Pandora Hunter. I didn't look into why they named it that because it was published in Emeginiana, which is one of the papers we don't have access to. But there were so many of them, I didn't really have time to get into all the details anyway.
Maybe it had something to do with Pandora's box.
I think so. That would be a cool reason. Or somebody that was mad at Pandora for opening the box and therefore was going to hunt them down. I don't know.
Could be.
And then Fernandezorum, I assume, is named after someone named Fernandez, because that's what it looks like. They didn't find a skull, but they did find at least some tail vertebrae and part of a foot. So a little bit. It's kind of like what they typically find with sauropods in the area. A few vertebrae, part of a leg, and that's it. The next dinosaur was actually found in Africa, although it wasn't really found just now. It was found a while ago with some other dinosaur remains, and Paul Serrano was kind of reviewing some ornithomimosaur taxa that were from the area and decided to name a new one from amongst the debris.
Debris?
At least that's what the abstract makes it look like. This one was also published in Emeginiana and written by Paul Serrano. Solo, no co-authors on this one.
Oh.
Kind of weird. It was about 40 million years later than the last dinosaur we mentioned, putting it in the early Cretaceous, because that's all that 40 million years does, is bring you from the late part of one period to the beginning part of the next period, since dinosaurs were around forever. And Paul named it Afromimus tenerensis. And Afromimus is because it's from Africa, and then mimus means mimic. It's probably because it's an ornithomimosaur, and they just often name those mimic at the end with the mimus.
It's still kind of funny.
Right.
Africa mimic.
Yeah, that's kind of a weird name. Specifically, they found it in Niger, or Niger, which is apparently the right way to say it. I don't know, and I'm so bad with the French. And then tenerensis comes from the word tenor, which is the Tuareg word for the area that it was found in. And Tuareg is like a native people's language from the area. It's pretty cool. I like it when they name dinosaurs like that. Like the first dinosaur, they didn't find any skull for this one, but they found some tail vertebrae and part of a leg, not a foot. So it's slightly different than the last one. And the third dinosaur that we're going to talk about, and last new dinosaur, was a titanosaur, but it's not from Argentina. We've got that theropod from Argentina, and now we have a titanosaur. This one's from China. And like a lot of the remains from Argentina, they only found one bone. In this case, it was most of a humerus. and that's kind of the upper front leg of the dinosaur. And it was from the late Cretaceous. It's actually the first titanosaur from the late Cretaceous from the Shandong province, which is the part of China that it's from. And the reason that they think it's a new species is because this humerus is more robust than other dinosaurs. They said it has a robustness index of 0.39. I don't know what that means, but apparently that's pretty high on the robustness index scale for sauropod humerus.
All right.
The bone was about 1.3 meters long, or about 4 feet, so pretty big for an upper arm bone. And
robust,
yeah,
one might say.
They really might. Especially because it wasn't really round. It was a lot thicker in one direction than the other. So it kind of looks more like a shoulder blade or one of those types of bones that's kind of flatter in one direction than another. And they named it a very, very long name, especially for a Chinese dinosaur, where you get things like Yi Qi. They named it Zhucheng Titan as the genus, and the species is named Zhangjia zhuangensis, I think, which is really hard to say. I'm not sure what it means because the paper was all in Chinese. And even though I speak a tiny bit of Chinese, I cannot read scientific Chinese traditional characters. The little bits that were in English, mostly the abstract, say that it looks like Opisthosilicidia, which is from Mongolia, so it's not too surprising since it's nearby. But funny enough, another paper this week suggested that Opisthosilicidia is a junior synonym of Nemegtosaurus. So the one that is most like might be Nemegtosaurus instead of Opisthosilicidia. So there you go. You got a new sauropod, a new theropod, and a new ornithomimosaur.
Busy end of the year.
Yeah. None of them were like particularly amazing finds because we didn't get any skulls. It's mostly vertebrae and like partial limb bones, but still cool. Kind of filling in some gaps at least.
How many of these were open access?
0.
Oh, that's too bad.
Maybe the last one, but all the publication parts were in Chinese. So I'm not sure if that was an open access journal or if it was just something that I could get into.
Because I was going to say they could have been part of the PLOS Paleo Community Top 10 Open Access Taxa of 2017 contest.
Probably not, though, because I think this was published before a couple of them.
Oh, true. Good point. But that was my way of leading into the next story, which is that PLOS One published the results of the PLOS Paleo Community Top 10 Open Access Taxa of 2017 contest. And there were some write-ins, so I'm curious if maybe somebody wrote in any of those. But this year, they said over 40 papers were selected that represented plants and fungi, invertebrates, and vertebrate organisms that were published between December 1st, 2016 and September 30th, 2017. But people were also encouraged to write in nominations, especially new taxon that was published before the contest closed on November 15th. So if any of those papers were before November 15th, maybe. But anyway, number one this year is Ecolostomus cuvaceae, which is an ancient trumpfish, and paleo artist Brian Eng illustrated it since it was number one. And then 4 dinosaurs made the list. There's Borealopelta markmitchellii at number 2, Zool cruivastator at a number 4 and 5 tie with Gondwanagaritzes magnificus, I think that's how it's pronounced. It's the oldest fossil mushroom. And then Daspletosaurus horneri was at a number 6-7 tie with Shringosaurus indicus, which is an herbivorous archosaur. And then there was Isaberosaura molensis at number 9, and that's an herbivorous dinosaur.
Yep, and we covered all those. Hooray. Didn't miss any of the most important ones, at least.
Good. And Dr. Andy Farkey is the one who published the results of the contest, and we got to meet him when we were visiting the ALF Museum over the Thanksgiving break in the U.S.
Yeah, it was really cool. He mentioned that they tried to open it up to more than just dinosaurs because there's always non-dinosaur people that are like, all you ever talk about is dinosaurs. What about all the other fossils? So, yeah, they made an effort to bring in non-dinosaurs, but dinosaurs still ended up with almost half of the list because there were just so many cool dinosaur discoveries this year.
Yeah, so Gabriel Philip Santos, who's the collections manager at the Alf Museum, showed us around and gave us a history of the place and a really great tour. And also, that's where we learned how to correctly pronounce the California state dinosaur. It's Augustinophus, not Augustinophus. So we will try our best to remember that in the future. And it's because of the Augustin family.
Yes.
Who is affiliated with the Alf Museum.
Yep.
So the full name of the museum is actually the Raymond M. Alf Museum of Paleontology, and you can visit it in Claremont, California. And it's called the Webb Schools, and it's the only nationally accredited museum of paleontology on a high school campus in the U.S. It's actually a boarding school.
It's pretty crazy that this high school has this really nice paleontology museum.
Oh, yeah, Garrett and I were very jealous.
The museum is nicer than a lot of other paleontology museums we've been to that are just a museum on their own. And then this one's part of a high school, and it's just amazing. It's crazy.
Yeah. And students, they can take these paleontology courses and go on digs, and a lot of them have actually published scientific papers of their work. It's amazing.
That's pretty cool.
Yeah, and they have state-of-the-art equipment. And if you wanted to learn about what it's like to work in a museum, you can help out after school. And it was just really great. And the museum itself, it's bigger than it looks from the outside. And it's set up so that you kind of walk in a circle. And as you walk, you go through different periods of time. And we posted a whole bunch of pictures on our Instagram. So you should check it out at I Know Dino. And we may have more to say about this museum in the future.
And next up, thanks to Damien for sharing this with us on Facebook, Ping Wu and others published an article in Molecular Biology and Evolution that got picked up by tons of media sources. And it's all about an Evo-Devo study, which is, as a reminder, Evo-Devo stands for Evolutionary Developmental Biology.
Nothing to do with the band.
No. And what that means is that they're guessing about, in this case, how non-avian dinosaurs evolved into modern birds based on some of the developmental characteristics in modern birds. One of the main examples that I can think of is how, if you look at a human developing as a fetus, you see like it almost has gills and things like that at certain phases, and that's because we evolved from fish. So, yeah, you can see this kind of stuff in development. It's not nearly as simple as going through all the phases of evolution, but you can find certain genes, and now that we know how to manipulate genes during this sort of embryonic phases, you can kind of manipulate what the animals look like, and you can find out what kind of genes might have caused some of these changes. When you know that birds are related to alligators, you can kind of make a bird look more like an alligator if you know how to go back and manipulate the genes.
Chickenosaurus.
Yep. So in this case, they were looking at the genes that manipulate feather growth, and the researchers found a bunch of what they called feather-associated genes. They looked at about 500 genes, I think, and they narrowed it down to about 102 that were feather-associated. And then there were a few key genes that really affected the process. What they did, they called upregulating. And what that means is they basically made the genes express themselves more in these certain embryos, and they would do different genes in different embryos to see what kind of effects they had. And they did it on both chickens and alligators. And the key to that is those are basically two pieces of the dinosaur lineage that are still around now. So even though alligators didn't evolve from dinosaurs, they split off close to when dinosaurs became their own thing, which is what we call archosaurs. So it's a good way to kind of compare when these genes might have shown up. And what they found was that they could mess with these genes and they could cause scaly areas to curl or branch, which in the case of scales makes them look kind of ridged, like a Ruffles potato chip kind of thing. Or they could make them change shape, like they could make them elongate, kind of starting to look a little bit like a feather. And if you think about it, we've talked about feather evolution a little bit and how you start out and you need kind of a strong central structure, but then it branches out into a bunch of fine little feathery bits. And then those themselves have little hooks and things that link together so that it creates a stronger feather that maintains its shape and is useful for flying and things like that. So you need quite a few steps in order to grow a feather like that. And if you only do one or two of the steps, you can end up with something like a fluffy downy feather, or you might end up with something that is typically called a proto-feather that's basically like hair, but it's made out of what scales are made out of, not what hair is made out of. So when they applied these same techniques to the chicken scales on the chicken foot, they got feathers to grow between the scales, which was really interesting. And they looked a lot like dinosaur proto-feathers, those bunches of fine hair kind of looks. And what the author said to BBC was, quote, "In human evolution, the great achievement is the brain. In birds, it is the feathers."
Yeah, that's cool to fly, but I think we won that.
I guess, if there's a winning and losing side. But really, if you think about it, like the process of primates going from relatively unintelligent to smart enough to know how to build all this stuff and make podcasts, you you need quite a bit of similar levels of evolutionary advantage in order to go from just scales to these really complex feathers. And piecing together exactly how that happened is a pretty amazing thing to do. And it could help us learn a lot about how dinosaurs evolved from having scales to having feathers. And also, we still kind of wonder if any sorts of other archosaurs might have had feathers. We think that pterosaurs probably had at least some sort of like fuzzy covering, which would be related to these sort of proto-feathers, although it doesn't seem like they evolved into the fancy flight feathers that modern birds have. But it'd be really cool if you could piece that together just by looking at modern chickens and alligators. We have another follow-up on the Ornithocelida, or Ornithoscelida, debate.
Nothing to do with the pronunciation.
No. It's courtesy of a Nature article titled "Untangling the Dinosaur Family Tree," written by Max Langer and others. And what they did was they took a look at the Ornithocelida arrangement, meaning that theropods and ornithischians are together and sauropods are off on their own, and Saurischia is kind of left by the wayside. So what these authors did is they reanalyzed the data set, and when they put in their own values for the characters of the bones that Barron put in, so basically that's things like a million little measurements, angles of things, and lengths and widths and all sorts of different elements, and you have to correct for things like distortion, and it's very complicated. But when they analyzed it, they ended up with the supposed traditional classification, meaning the original Saurischia and Ornithischia groups. And I think they summed up their research pretty well in the conclusion. They said, quote, "The data we present here lead us to be skeptical of the new phylogeny proposed by Barron et al. We are excited about the Ornithocelida hypothesis, which will certainly reinvigorate the study of dinosaur origins. However, we do not currently find strong evidence to discard the traditional Ornithischia-Saurischia division, and we must also entertain a third possibility that was articulated in the 1980s, end quote. And the 1980s theory that they're referring to is actually the dinosaur heresies theory that we used as a fun fact back in episode 129. So if you want to hear more about that, you can listen to that. I don't think that's quite as well fleshed out, just because the dinosaur heresies theory also proposed removing some of the dinosaurs from the dinosaur classification and doing some more radical things. There were quite a few things that were proposed there, and it didn't have any sorts of statistical analysis or anything ascribed to it. And Barron et al. Responded to this paper, which makes it fun. They point out that they changed about 2,500 scorings of these characteristics, and that was about 10% of the data.
It's a sizable chunk.
Yeah, that is quite a bit. But they completely disagreed with one of the dinosaur scores in particular, which is Pisanosaurus. Basically, there were a couple things like they used a ratio of the length of the head to the length of the body and things like that, but we don't actually know the length of the body and the length of the head. They're kind of inferring it from other elements that Barron doesn't think is something we should be doing, basically. And if you change those numbers back and leave all the rest of the 2,500 scorings the same, you end up getting Ornithocelida back again. So it's a very sensitive model to very small changes early in the dinosaur phylogeny. And the original authors also pointed that out. And that's why they say that 1980s theory is basically just as valid, because you can get to that point by making certain small changes. You'll get these totally different trees. So in scientific terms, it's really not statistically robust. And we need to find more fossils. It's pretty much the only way to settle the debate, because if it's so sensitive to just a couple tiny little measurements, like single individual's bones, you really can't base the whole structure of Dinosauria on that. So still don't really know.
That's always the answer. We need more fossils.
It really is. Especially in this case, though. Like, just how close all these trees are statistically is pretty crazy.
In some other news, National Geographic reported on these advanced X-ray scanners that can hopefully help prevent fossil poaching. So the scanners can create, quote, a map of chemical, quote unquote, fingerprints that can match a fossil signature to that of a particular region, end quote, which would be useful in places such as Mongolia, China, Morocco, and Argentina. And these devices, they're portable X-ray fluorescence scanners, and they show details of the geochemical makeup of fossils and rocks. So Federico Fanti, a paleontologist at the University of Bologna, and a team used the scanner and camera drones to record these geochemical signatures and create a detailed map of fossil sites in the Western Gobi. So the idea is that you can scan any fossil from Mongolia and know immediately where it came from. So then fossils that are returned to Mongolia are easier to identify in terms of where they came from and how old it is, and you don't lose some valuable data that you might if you don't have all of the information. And this could also be helpful for learning more about fossils that were collected and stored a long time ago, though they said it's still just one tool to help fight against fossil poaching. And you also need education, collaboration with scientists and governments, and you want to be monitoring regions with fossils.
Yeah, it's pretty interesting. I read a little bit into the scientific paper there, and the chemicals specifically that they're looking at were calcium and silicon for the Namek formation, and then some of the bones in that formation also have different patterns of titanium and uranium, which can be useful. So the calcium and silicon, while statistically powerful, I could see being, potentially fakeable, or if not, they're so ubiquitous that you might get a little bit of overlap with different areas. But titanium and uranium are a little bit less common, so hopefully that wouldn't happen.
We've got a few different exhibit news. So from now until February 17th, you can see the new exhibit Dinosaurs of New Mexico at the Carlsbad Museum and Art Center in Carlsbad, New Mexico. And it's a traveling exhibit by the New Mexico Museum of Natural History and Science. And if you're there, you can hear how a hadrosaurid may have sounded, feel the texture of dinosaur skin, and see the cast of a T-Rex footprint. There are also Pentaceratops and Camarasaurus fossils. In Canada, the Royal Ontario Museum will be having their annual Madeline A. Fritz Lecture on January 30th at 7 p.m. And this year, Dr. Mary Higby Schweitzer from North Carolina State University will be speaking about dinosaurs under the microscope and how bones fossilize at the molecular level, and as well as recent findings from the lab. So you do have to buy tickets for this one. They're on sale now, and they cost $20, and after the lecture is a reception, so could be a fun evening. Something happening a little bit sooner is in Scottsdale, Arizona. Pangea Land of the Dinosaurs is having its grand opening December 12th. They actually had to reschedule it. We talked about it in an earlier episode. Originally, it was supposed to be November 24th. and I couldn't find a reason for why it had changed, but anybody who bought tickets for between November 24th and December 12th can reschedule their visit. And Pangea Land of the Dinosaurs, just as a recap, it's an indoor center with over 50 animatronic dinosaurs, and then they have activities like face painting and balloon art and fossil excavations. Next, a little fun, I guess, piece of history. The Smithsonian National Museum of Natural History published a post on Charles Whitney Gilmore, the, quote, forgotten dinosaur hunter. So Charles, he was actually known as Charlie to his friends. He was one of the last big names from the what they call golden age of dinosaur hunting in the U.S. And he was born in 1874 near Rochester, New York. And when he was 6, his aunt took him to visit Ward's Natural Science Establishment. And that is what made Charlie want to work in museums. So he started collecting rocks and fossils and bird eggs and insects, and apparently even tried out taxidermy with an unsuccessful attempt to restuff a toy elephant. At least it was a stuffed toy, so hopefully not too jarring of an experience. But in 1900, he met John Bell Hatcher, who was working for the Carnegie Museum, and hired him to help collect late Jurassic dinosaurs. And then in 1902, he was hired as a full-time preparator at the Carnegie. And in 1904, he prepared Hatcher, the Triceratops, which is the first Triceratops put on display, as well as an Edmontosaurus for the National Museum in D.C. In 1904, ground was broken for the new National Museum, and Charlie kept really good records from then until his death in 1945 about museum tasks that were accomplished each day. They said that's what made it so easy to write this post about him. He became the curator in 1924, and he did a lot of field work, too. He also helped prepare and mount the 70-foot-long Diplodocus skeleton at the museum, which went on display in 1931, and apparently it took 2,545 working days to excavate, ship, prepare, and mount.
Oof.
Which is much longer than it sounded like he anticipated.
Yeah.
And in his personal life, he married Laura Cotant in 1902 and had 3 daughters, and people thought that he was a very kind and modest person, and his colleague George Gaylord Simpson called him, quote, kindness personified.
That's nice.
Yeah. So that was a nice little history, because we hear his name a lot. I don't think we know too much about his personal life anyway.
Charles Gilmore, yeah.
Yeah.
Yeah, you see Gilmore associated to a lot of different things.
Mm-hmm. Next, CBS News reported on Grand Staircase National Monument in Utah and the controversy over it possibly becoming a smaller monument and opening up more land to more commercial development. So, for some background, it was designated a national monument in 1996 and was meant to be an outdoor laboratory. And since 1996, 25 new species of dinosaurs have been found there, but there was a lot of controversy because it limited residents' ability to graze cattle and extract minerals and build roads. So if the current administration in the U.S. decides to shrink the size of Grand Staircase, there's a chance that fossils that haven't yet been discovered could be destroyed.
Yeah, and I think the way that the review of these national monuments and parks was written, it's basically, we're going to review every park from 1996 onward. And a lot of people think it's specifically because of this park because it's so big and seems to have oil under it.
Mm-hmm.
So hopefully that doesn't change because we want more new dinosaurs.
Yeah, we're always talking about you need more fossils.
Yep. How are we ever going to settle these debates? And speaking of Grand Staircase Escalante National Monument, Jim Kirkland and others recently published a paper about all of the geology of dinosaurs in Utah. And luckily, it's in an open access journal called Geology of the Intermountain West, which I had not heard of before this. But it's a super in-depth description of Utah's paleontology, and it has lots of beautiful images. It's got drawings and pictures of the formations, as well as their subunits, or what are referred to as members, like there's a lower cat and upper cat and all sorts of things like that, that break down into very specific time ranges. And the group went through and really put a hard look at all these different ages of the rocks. So they have a very good defined range in time for all the stratigraphy, along with the drawings and pictures of the rocks themselves. They also put in examples of the fossils from the areas, and then It has one of the coolest pictures I've seen in any paper ever. And it's titled Distribution of Dinosaurs in the Mid-Mesozoic of Utah. And it shows all these different formations and members, and it points to them and shows all the different dinosaurs that were found in that formation in Utah.
It's pretty cool.
So, for example, at the bottom, the oldest formation at 150 plus million years ago is the Morrison Formation, and it's got Allosaurus, Torvosaurus, Stegosaurus, Martiasaurus, Apatosaurus, Camarasaurus, Ceratosaurus, all the
good ones.
Lots of other ones. Not all the good ones, just because you like Apatosaurus. And then if you go up a little bit, you get into the Cedar Mountain Formation and the different cat members, and you get things like different ankylosaurs, you get more sauropods, you get, Gastonia, Moabosaurus, and Utah raptor. And then as you get even newer, you get like troodontids, you get other tyrannosaurids, you get even more ankylosaurs and acrocanthosaurus, and there's just so many cool things. And you even start to see bird footprints and tracks and teeth showing up. So cool. So it's a really great picture, especially if you're in Utah or interested specifically in Utah paleontology or just Western North America paleontology, because it's about as good as it gets. In fact, he says in an accompanying post to this article, quote, Utah has the most complete dinosaur record located in any one area in the world, as well as currently the Utah Geological Survey Paleontology section recognizes the presence of 27 sequential, non-overlapping dinosaur faunas spanning 165 million years from 230 to 65 million years ago.
Wow.
Pretty awesome. And reading this article, actually skimming it because it's over 200 pages long, it's like looking at a really excellent book on the dinosaurs from Utah, and it's open access, so it's like a free book with tons of good pictures and drawings, and I highly recommend it for anybody who's interested in learning a little bit more about these dinosaurs and where they came from and which dinosaurs they were around at the same time too.
Everything.
Yeah, it's pretty awesome.
Speaking of learning about dinosaurs, Cal State Fullerton has a new course called Dinosaur World, and in this course, students learn the evolution of dinosaurs and how they became extinct. So it also covers dinosaur anatomy, behavior, and diet. And Scott Matt, who teaches the course, said, quote, I hope that students take away the notion that life in all its forms is actually quite similar when you look at it in terms of our basic needs and functions and behaviors. Dinosaurs are no different, and there are countless comparisons one can make to show that for every seemingly odd dinosaur that we discover, there is probably some animal alive today that is living a similar life under similar circumstances, utilizing similar behaviors, and wielding a similar anatomy that can be used to make sense of these strange creatures of the past. End quote.
Yeah, that's true. And a lot of times some of these dinosaur revelations that come out come specifically from just watching modern animals, like especially birds, because they're similar. They're in some of the similar niches. They talk about burying eggs, and we know that dinosaurs buried eggs. So you just watch modern birds bury eggs and how they keep them warm and things like that, as well as like display structures too. We think of some of the display structures as being totally crazy, but if you think about things like peacocks and animals like that, you're like, oh yeah, I guess sometimes animals do just wacky things for display that are not useful in any other way.
Or that one bird on planet Earth.
Oh, yeah. Yeah, there's some good ones.
I forget the name of it, but it pops up in this green thing from its neck.
Looks like a giant smiley face. Yeah. I love that bird.
In media news, there's a new 6-second teaser for Jurassic World Fallen Kingdom. It's not really a teaser. It's actually Colin Trevorrow tweeted the clip, and it shows Owen Grady giving a chin scratch to a baby raptor, and the raptor looks pretty happy about it. It's pretty cute. I think I watched it on loop a few times.
Nice.
We also have some more details about the dinosaur on Marvel's Runaways show, now on Hulu. Bustle published a piece. This piece has spoilers from the comics. I started watching the show. I think there's 4 episodes out as of this recording, and it took a little longer than I would have liked to get to the dinosaur, but it's there. And
how many episodes in was it?
I want to say either the end of one or maybe the second one.
Oh, okay.
I can't remember because I watched it all together. But there's not much of it.
Oh, it takes a while to like actually get a good shot of it.
Yeah. It's kind of just running around for a little bit.
Gotcha.
And there's not much to it yet. But it sounds like it'll become more of a character, at least from what I've read. But according to Bustle, this dinosaur is known as Old Lace. We haven't gotten to the dinosaur having a name in the show yet. And it's a genetically engineered Deinonychus. And Gert, one of the characters, her parents went on a shopping trip in the future and bought Old Lace to protect her, which we don't know this in the show yet. So, spoilers again.
She went to the future to get a dinosaur.
Not her parents.
But it seems like going to the future seems weird.
Well, if you have a genetically engineered something.
I guess so, yeah.
So, Old Lace is telepathic and can communicate with Gert.
Oof.
Yeah. But what's cool is on the show, Old Lace is actually a combination of a big puppet and CGI made by the company Legendary Effects. And it takes 6 puppeteers, and they're able to pump air to show her inhaling and exhaling, as well as show her emotions. So I actually read this article before I started watching the show, and I was kind of looking to see if I could tell the difference between the puppet and the CGI. It's difficult, but...
Yeah, I'm guessing they probably use the puppet when it's more interacting with people. That's usually when they end up doing stuff like that. So you can put your hand on it and things like that, and it doesn't look super weird.
Yeah.
That's cool. I love a good dinosaur puppet.
Yeah, me too. Next in Ankara, Turkey, there's a giant T-Rex statue that's been removed. It was nearly 10 feet or 3 meters tall, 33 feet or 10 meters long, and it was put up 2 years ago to promote a new theme park, and now it's been replaced by a giant robot statue that's meant to look like an Autobot from Transformers.
That's funny.
Yeah, it's a fun little tidbit. And last, I just want to share a quick note about a cool Reddit Ask Me Anything AMA happening later this week. So thanks to the Royal Tyrrell Museum who shared this with us. So this Friday, December 8th, Doctors Caleb Brown and Don Henderson are talking about their research on Borealia pelta at r/science. And we got to speak with Dr. Caleb Brown in episode 149, Robocosaurus, if you want to hear that. And if you have any follow-up questions for him, check out the AMA. We'll post a link so you can easily get to it from our show notes.
I might have to join and ask some questions.
Yeah, you got some follow-ups?
I might.
Good. December 8th.
Thanks. And before we get into our dinosaur of the day, we want to again thank our sponsor, TRX Dinosaurs. It was funny, while you were talking about the Jurassic World Fallen Kingdom chin scratch of the baby raptor, on TRX Dinosaurs Instagram, they posted a video of scratching underneath a baby raptor's chin in the same style as the Jurassic World Fallen Kingdom clip. And it's pretty adorable.
There's also a clip of that same baby raptor kind of nuzzling the cat.
Yes. And then the cat starts like pawing at it like it's going to scratch it.
Yeah.
Which probably isn't good for the foam. Just saying.
Well.
Don't let your cat scratch the crap out of it if you get one. They didn't really let it get at it too much, at least. Yeah. And so if you want your own baby raptor that you can simulate Jurassic World Fallen Kingdom.
Pretend you're Owen Grady.
Yes. Well, is it, I don't think we know if it's him that's rubbing it, do you?
Yeah.
Oh, you do? Okay. Well, then you should get one of these if you're a big Owen Grady wannabe.
Oh, also good for cosplay.
Oh, true. Yeah. Yeah, that's a good point. Because I think this would fall into like the price range of a lot of cosplay.
Yeah. It'd be really good quality cosplay.
Yeah.
Or if you just want a cool dinosaur sculpture around, these are very affordable. They're museum quality, so they're great for spicing up exhibits if you are looking to spice up an exhibit at your museum.
Or even just posing a set of them together, I think would look really great. And as we've said before, they're totally customizable. They make them all to your specifications, so you can pick out any kind of dinosaur you can imagine, and they'll work with you to make it look the way you want it to look and have the features and abilities that you need. But no matter what, they'll be really lightweight, and they will be upgradable. So that's really awesome.
It is. And you can learn more by visiting their website at trxdinosaurs.com or checking out their Instagram at trxdinosaurs.
See the latest cat videos / dinosaur videos.
Yes. And now on to the dinosaur of the day, Camarasaurus, which was a request from Cole via Patreon and Dinosaur4602 via YouTube. So thanks. It was a sauropod that lived in the Jurassic in what is now the Morrison Formation in North America, and the name means chambered lizard. This is because it had hollow chambers in its vertebrae. It was first found in 1877 by Oramel W. Lucas in Colorado, and it was named by Edward Drinker Cope in 1877, who paid for the bones. This all happened during the Bone Wars, as you probably guessed.
Dun, dun, dun.
There's 3 valid species. There's Camarasaurus supremus, Camarasaurus grandis, and Camarasaurus lentus, and the type species is Camarasaurus supremus. It's the originally named species, and the name means the biggest chambered lizard.
That's quite a name.
Yeah. And the Camarasaurus grandis means grand chambered lizard. That was also named in 1877. And then Camarasaurus lentus was named in 1889. Othniel Charles Marsh later named some sauropods Morrison grandis, but these are now considered to be Camarasaurus. There was also Camarasaurus lewisi, which was named in 1988 and originally classified as Cathetosaurus, but in 2013 another study split the 2 genera again. So Camarasaurus, as you might imagine, being a Bone Wars dinosaur, has a few synonyms. They include Collodon, Morosaurus, and Untosaurus. I'm not totally sure how to pronounce that. It's Uintosaurus.
You might be the first person to try to pronounce it in 100 years. It's hard to say.
Yeah, I have no idea. So Camarasaurus is one of the most commonly found sauropods, and a lot of Camarasaurus skulls have been found. Cope, he was no Gilmore. He wasn't the best record keeper. And he labeled some Camarasaurus fossils, which are now at the American Museum of Natural History, with letters and numbers to correspond with a set of dig site sketches. But he threw away the dig site sketches, so it's not clear what he meant. And some copies have been found, but not enough to piece together the full picture.
Oops.
Yeah. We covered this when we talked about Brontosaurus back in episode 100, but Brontosaurus was originally given a Camarasaurus skull. Brontosaurus, though, is a diplodocid, so its skull was more likely elongated and narrow and not so boxy. Charles W. Gilmore, speaking of Gilmore, found a nearly complete skeleton of Camarasaurus in 1925. It was a young Camarasaurus, so drawings from that time depict Camarasaurus as smaller than what we now know it is. Camarasaurus is a basal macronarian, which is a group of sauropods that kept their heads up high, and they include Brachiosaurus, Giraffatitan, and Lucititan.
Kind of the pose that most people imagine when they think of sauropods.
Mm-hmm. Being really, really tall.
Mm-hmm.
And Camarasaurus grandis is the oldest species of Camarasaurus. Camarasaurus lentus and Camarasaurus grandis probably coexisted for several million years, and they were slightly different, so it's possible that they filled slightly different ecological roles. And then eventually Camarasaurus grandis disappeared, and then Camarasaurus lentus disappeared around the same time that Camarasaurus supremus appeared, which may mean that Camarasaurus supremus evolved from Camarasaurus lentus. The only difference between Camarasaurus supremus and Camarasaurus lentus is that Camarasaurus supremus was larger, and also it was found in the upper parts of the formation, so it's the newest one.
I wonder what Jack Horner and John Scannella would have to say about that. Because that's pretty much the exact differences, but actually that's less differences that you see between Triceratops and Torosaurus.
Ah, maybe we'll have to ask them sometime.
I know what they would say. They're lumpers through and through.
So Camarasaurus lentus could grow up to 49 feet or 15 meters long, and Camarasaurus supremus could grow up to 75 feet or 23 meters long and weigh up to 47 tons. It's huge.
It's huge. It's huge-ish, right? It's bigger than anything today, but it's still smaller than a lot of other sauropods were.
That's true. That's true. Still, just ginormous to me.
Yeah, you still react the same for sure.
Yeah. And I don't even know that I could tell how much bigger one was if I was up close, you know?
Probably not.
Yeah. So Camarasaurus had pneumatic bones with air sacs in the vertebrae that connected to the lungs, and its forelimbs were shorter than its hind limbs. It had 5 toes and sharp claws on its feet. And for a while, it was thought that Camarasaurus had a second brain because it had this enlarged space by the hips, but that's no longer thought to be true. And that happens to a lot of sauropods. It probably had a stiff, muscular neck, and it probably traveled in herds or groups of families. And this is based on 2 adults and a juvenile that were found to have died together from drowning while crossing a flooded river. They probably didn't take care of their young like other sauropods, and this is based on nests found with Camarasaurus eggs found in lines. They weren't arranged nicely, and the eggs may have been laid near undergrowth so that the hatchlings could run for cover.
Well, that was nice at least.
Yeah, give them a little bit of a chance in the beginning.
It's better than like how turtles are, where they try to rush towards the ocean, and a lot of times every single one of them gets eaten.
Oh.
Yeah.
Well, Charles Marsh at one point thought that Camarasaurus gave live birth, like sharks, which develop eggs in the body and give live birth, but there's no evidence for this.
Oh man, that'd be cool though.
It would be.
I'm really kind of hoping still for a dinosaur that gives live birth. There's no reason it couldn't happen. It evolves all the time.
Yeah, that would be really interesting to hear about.
It's actually funny that you mentioned sharks because a lot of sharks do lay eggs. But some
not
of
all.
Some of them decided to, decided is probably a strong word.
Yeah.
But some of them evolved to live birth because it's better.
It's a great white, right?
Yeah, there are others too, but yeah.
Back to Camarasaurus. Camarasaurus had a blunt snout and a squarish arched skull, and it may have had a beak. There's no evidence found for this yet, but some Camarasaurus teeth have been found in the lower jaws that are not connected to the jawbone exactly, but were preserved in the right place. And this may have been because of soft tissue that kept them there. So a beak would have also helped it shear through plants. And Camarasaurus had spatulate teeth. Their teeth were strong. It could probably eat tough vegetation. And since it probably held its neck up high, it was a high browser. One Camarasaurus specimen found had evidence of soft tissue, the gums, which show that Camarasaurus probably had gums covering all but the tips of the crowns of its teeth. And the specimen is nicknamed E.T. because when it was first found, all you could see was a finger bone coming out of the rock. Camarasaurus probably did not swallow gastroliths and instead had strong teeth that were replaced about every 62 days, so it may have chewed its food.
Oh man, I wish I had that.
It's a lot of teeth.
You never have to brush your teeth.
Ooh.
But they'd always be like in such great shape. Never have to worry about cavities. Oh man.
I guess.
I'm so jealous of animals that get new teeth all the time. We'd have some janky smiles, but it'd be totally worth it.
Yes. I think the food we eat is better than the food they ate.
Oh, true, yeah.
So vegetation at the time included ferns, conifers, green algae, fungi, mosses, horsetails, cycads, and ginkgos. And Camarasaurus lived in a semi-arid environment with wet and dry seasons. It also lived among snails, fish, frogs, salamanders, turtles, lizards, crocodilomorphs, pterosaur-like animals, and early mammals. And other dinosaurs that lived among Camarasaurus include Diplodocus, Apatosaurus, Brachiosaurus, ornithischians such as Camptosaurus, Stegosaurus, Dryosaurus, theropods like Saurophaganax, Torvosaurus, Ceratosaurus, Ornitholestes, and of course, Allosaurus.
And you can see virtually all of those in Jim Kirkland's picture of the dinosaurs of the Morrison Formation, since that's where it's from.
Way to bring it back around.
I think there's even more than that in that picture. It's crazy how much we know about the Morrison Formation.
A partial Camarasaurus grandis skeleton found in 1992 at the Brian Small Stegosaurus quarry of the Morrison Formation, speaking of, was found to have pathologies that would have made it difficult to move its forelimb. There's a lesion on the bone that looks like it's made of woven bone fibers. It probably healed, but with a growth that would have made it difficult to forage for food and escape predators. And the pathology may have been caused by an avulsion injury, where part of the bone and its muscle attachment was ripped from the rest of the bone.
Yeesh.
This is according to McWhinney and others. And that may have been because of a slip or a fall or repetitive strain, maybe because Camarasaurus lived in an area of uneven ground and then strained itself walking. Camarasaurus pelvis found in Dinosaur National Monument in Utah shows signs of Allosaurus bites. Allosaurus didn't necessarily kill Camarasaurus. Instead, it may have eaten the Camarasaurus after it died. One Camarasaurus specimen was prepared and put on exhibit at the 1933 World's Fair and is now on display at the Smithsonian National Museum of Natural History in Washington, D.C.
Or at least it was.
Oh, good point.
It'll probably be back in a couple of years.
Yeah, in some form. There's a mounted Camarasaurus lent from the Smithsonian that was on display at the Dallas Federal Building as part of the 1960 Expo to celebrate Texas's 100th birthday. You can see a Camarasaurus at the Carnegie Museum of Natural History in Pittsburgh, Pennsylvania, and you can also see a Camarasaurus in situ at Dinosaur National Monument. We've seen it.
And we have a miniature version of it on our wall.
Yeah, we do. And
It's
lots of
pretty great.
pictures of it.
Yeah. Wait, there's actually an adult and a juvenile. We have the juvenile version on our wall, which is pretty great.
Yes, so only 2 skulls left on the quarry face at Dinosaur National Monument are of Camarasaurus. And you can also see the neck bones of one.
Yep. And our fun fact of the day is that mammals were probably mostly nocturnal until dinosaurs went extinct. And this might have resulted in what's referred to as a nocturnal bottleneck. I had never heard of that.
Oh,
but
yeah, interesting phrase.
yeah, there's a recent paper by Roy Maurer and others that talks all about this and how mammals look the way they are now. And in particular, this nocturnal bottleneck. So if you're wondering what it is, you're just like me. And the idea is that basically only nocturnal mammals survived during the Mesozoic. So that's the kind of bottleneck. There weren't really any mammals before the Mesozoic. There were these animals called synapsids, like Dimetrodon, that mammals evolved from. But Dimetrodon was probably diurnal, if not cathermeral, so not nocturnal, in other words. And it went extinct when dinosaurs showed up, along with most of the other synapsids. In fact, all of the synapsids that weren't mammals went extinct. And so these nocturnal mammals had to evolve a lot of new features to compete at night. And they include things like having large eyes that favor low light over precision. If you think about like hawk eyes, they're very precise, but they don't work very well at night. They also have adaptations for when the light is even too low for eyes to work at all, like a broad range of hearing. We've talked about how humans have a much broader range of hearing than dinosaurs probably did, as well as having a better sense of smell and whiskers so you can feel around in the dark. So you see these kinds of features in most modern mammals, including ones that are only awake during the daytime. Like humans have big eyes and a decent sense of smell and a good sense of hearing. We really don't need all of those things. So it could be a result of this nocturnal bottleneck where all of our ancestors had these features, and so they've kind of carried on. So pretty interesting. We might have dinosaurs to thank for some of our senses.
Does that mean it's okay to be a night owl?
I think so. I think it also shows that it's really fortunate that our distant ancestors were at least partially nocturnal so that they didn't get completely wiped out.
Yeah, that's true. Yay, thanks, ancestors.
They did good.
And that wraps up this episode of I Know Dino. Thanks for listening. And don't forget to subscribe to our podcast so you don't miss out on any new episodes. You can also join our growing community on Patreon at patreon.com/IKnowDino. Thanks again, and until next time.
Thank you for listening to I Know Dino. If you have any questions or comments about dinosaurs, we'd like to hear from you at plesiosaur@iknowdino.com. And for more information on dinosaurs, go to iknowdino.com or follow us on Google, Facebook, Tumblr, or Twitter at I Know Dino.